I'd like to introduce myself. I'm Rusty Bowling from Sun Hydraulics, and it's great to be here in Orlando to share with you at SolidWorks World. Our presentation is the purpose and benefits of getting industry involved in education and bringing industry into the classroom. Sun Hydraulics is a manufacturer of hydraulic valves. We make cartridge valves, we make manifolds for our valves. I have some samples here on the table for you to look at. They're done in acrylic, so you can see the chambers and how the valves actually work. And I have a cutaway of a cartridge valve, and you can see how it works. Quite interesting to look at. One thing interesting about the valves is that we take these down to the high school and have the local students drawing them in SolidWorks, and then we check the drawings. A little bit about Sun Hydraulics was founded by Mr. Bob Koski. Mr. Koski started Sun Hydraulics in a one-room little garage behind his house and has built the company to employ up to 700 people. We're located in Sarasota, Florida, our main headquarters. We also have a facility in Kansas City. We also have in Korea, China, England, or Germany, Japan, and so we're a world company. We have our factory set up very well. Our floors are all epoxy painted, very clean environment. We do everything in-house at Sun Hydraulics. We do our own maintenance and fabrication. We have an automation department where we build our automated equipment, our machinery. A lot of robotics, a lot of CNC.
Okay. Hi, I'm Richard Platt. I teach at Southeast High School in Manatee County. Prior to teaching at Southeast, I taught at Braden River High School for 4 years, teaching SolidWorks and CNC. My background is, and click this right, I was a CAD designer at Johnson Space Center during the early days of the shuttle program. I was there at the launch of STS-1. After I left NASA, had to make a living. After I left NASA, I went to work for the company that made our computer graphics system. You may have heard of them years ago, a company called Intergraph. I worked for them for several years and then eventually involved into corporate sales where I went out and evangelized the CAD/CAM world. While at Southeast High School, we're a very small high school, low socioeconomic. We're in a kind of a rough neighborhood, if you want to call it that way. One of the big problems in our school is engagement. We got to get these kids who come from rough families and rough family lives to come in and be able to get excited about going to school every day. We have to offset our low socioeconomic, not get our school closed. We have the International Baccalaureate program there at Southeast. We have kids from all over the county, all over the world that come to the school. I have a girl from South Africa, kids from China. They're in my classroom. One of the big quotes about Southeast that I always thought was funny was they said, an engineering program will never work at Southeast. And that's absolutely not the case. In the last 4 years, in the Technology Student Association in Florida, Southeast was the state champion 3 out of the last 4 years. The one year they weren't was when my school at Braden River got them. They're the world champions in the F1 in Schools STEM program. F1 in Schools is a world competition where 32 nations compete with 9 million students. In Southeast, a little old school out of Bradenton, Florida, was able to go and win the world championship. And then the following year, they were able to come back and place in the top 3 again. 3 of our students have, in the last 4 years, have earned full rides to MIT.
I want to tell you a little bit about Manatee County, some facts. Manatee County was hit hard by the recession with unemployment as much as 17% at one time. Manatee County is a county that's based on tourism, what we might call a snowbird economy. We desperately in the needing of some diversity in the economy in Manatee County, needing some jobs for people to work. 71% of high school students in Manatee County do not go to college. I don't know if you knew that. And that's really an important part to think about. Administrators many times assume that all kids coming out of high school are going to go to college. That's not necessarily true. A matter of fact, according to the statistics, It's not true at all. Now, what's happening is these students coming out of college that aren't out of school that aren't going to college, they're not prepared to enter into the workforce. They're not work ready. And that's a problem. So what we want to do is we want to get them technically educated so they're ready to enter into the work field at a company like Sun Hydraulics. You could come to our company at entry level and go in with some training and be running some automated equipment pretty rapidly. Precision measurement is important, and to create drawings and read them. And so those are some things that when you bring industry into the classroom, for example, modeling our parts, teaching them to hold the tolerances, teaching them what the symbols mean, teaching them how to read prints is very important when they go for a job interview.
Okay. I'm glad that Melissa Morrow is here because she can, I think, testify to what I'm about to say. And probably, I'm sure, how many in here are teachers? Good. And you're what? Excellent. Glad you're here. Glad you're here. You're real relevant to be here. Right now, STEM is science, technology, engineering, mathematics, and putting engineering programs in all the schools a big push. But like Russ said, not everybody is going to become an engineer. Sometimes it's just not in the cards for them to go on to college and do that. However, with the push, what we're trying to do and what we're trying to do in our programs in schools is we're trying to meet the needs of industry and manufacturing. Our Chamber of Commerce have come to us and said, give us work-ready kids. His company, give us work-ready kids. And it's really a struggle for someone who's not been in the industry to teach a kid how to get work-ready. So our goal is to get these kids making higher paid jobs because the last couple of years, their college has gone up 22% a year. Inflation rates, at least in my home state of Texas, has gone up crazy expensive. So these kids are going to have to work their way through school if they don't have scholarships or bright futures. And we have to look at getting these kids into a position with or without college so they become a viable taxpayer and contributor to the community.
Sun Hydraulics is encouraged to go into schools to make a difference. We have intern programs at our company where high school students can come in and work in our facility and earn money. Now, before age 18, they're not allowed to run any equipment or anything, but they can do simple jobs like assembling parts, assembling valves, those kinds of things. Southeast, when I went there, their shop was absolutely a disaster. I don't mean a little bitty tiny disaster.
Big disaster.
I mean an absolute mess. There was stuff all over the place, machines sitting around that hadn't been used for years, collecting dust. How many of you seen that in schools? They're there, and I mean, man, they're holding on to those CNC machines. They're not letting them go. They're doing nothing. So we went in, and we created a vision. But first, we went in from industry, and we repaired those machines. I went there, I said, Rich, let's pull these machines out. We pull them out, set them on a table, put some power to them, try to figure out what's wrong with them. Some needed fuses, some needed some programming work, some needed tooling, different kinds of things. We got those machines out, we got them working, got them running. So then we started working on a plan, a structure, on a manufacturing model. And the direction that we want to go in is we want to create a manufacturing entity there at the school where the children coming in as freshmen or sophomores can start designing in SolidWorks, and then sophomore, junior, senior start building what they design. We invited Mr. Platt over to Sun Hydraulics for an intern program. He spent the summer there with us. He worked in the manufacturing on the floor. Mr. Platt has a design background. He's a great designer, but he has no manufacturing background. So that's like a recipe for disaster. Because one of the most important things about design is, can you build it? When I judge competition, I've judged SolidWorks competition for high school kids numerous times, and one of the things that I always looked at is, can the product be manufactured? And what types of material are we going to manufacture it out of? And so those things are really important when it comes to manufacturing. For Sun, it's a great opportunity. It's a great opportunity to work with Southeast High School and the IB program. It's a great opportunity to give back into the community. It's a great opportunity for us to be able to help young people develop their career. But one of the problems I've found working in the school situation sometimes is that some of the instructors, some of the teachers, they don't have real high humility level. They're not willing to humble themselves to the learning process. And one thing I liked about Richard, when he came on board, he was willing to say, you know what, I don't know anything about this. I need to learn. And you need to approach industry with an open mind. I can't tell you how many times that I've seen industry willing to come into the classroom, willing to help the instructors, and they're shut down because the teacher or the administrator knows more than the individual in the industry. And they leave that classroom, that facility saying, what's the use? They won't listen to what I say. I'm trying to tell him, and he already knows. Richard came to me. He asked for our help. He didn't ask for our money. One thing I want to tell you, when you go into industry, ask for their help. If you ask for their help and you listen and they see progress, they will give you the money that you need to support your program because they themselves become a part of that program.
A couple little points I want to add to what Rusty said. I really didn't know anything about manufacturing. I was clueless. And when I got to Southeast and Braden River High School is where I came from, they had all this CNC stuff, this collected stuff that had dust all over it and wasn't being used. And they said, well, let's get Platt to do it. He's the CAD guy. Well, yeah, I'm a CAD guy. I work for CAD companies and I actually worked for Dassault Systems at one time. And I'm like, well, I never use CNC. But how do you spell that? So I got in there and I tried to figure it out. And, we got it running with Russ's help. And the other thing about the manufacturing, I was clueless on it. I didn't have a clue. And so the Sun internship that I did was amazing. It's one of the best experiences of my life. Besides the fact I had to be at work at 5 a.m, it was really a great experience. Had my first workers' comp claim when I tried to file the end of my finger off on it, but that was a lot of fun. But Sun was great. So 6 years ago, they hired me to do this CAD stuff because I had this background working for Intergraph, working for Dassault, working for Silicon Graphics and these companies. But when we started at Manatee County, Autodesk was the problem. Plain and simple. We didn't like them. They didn't like us. We didn't like their cost. We didn't like their subscription thing that they have going on right now. And it's just, Melissa, God bless her, she knows exactly what I'm talking about. Her counterpart is my director at Manatee County, Doug Wagner. You mention Autodesk, and he just rolls his eyes and back of his head and goes, I'm not paying that money. And every year it was the same thing. Give us more, give us more. And what's funny, being from the CAD industry myself, is Autodesk got beat at their own game. They used to give the software away back in the 80s. Oh, take it, go use it, you'll love it. And then they come back and give you this thing called a dongle and make you use it. And then they come back and say, okay, it's $3,400 for a copy of AutoCAD. And then, and so what happened was SolidWorks said, no, let's take a different approach. And what we needed was a different approach too. We needed a 3D solid modeling for emphasizing manufacturing. These guys were demanding it. The industry is demanding that we come in with 3D solid modeling training students. So our decision, we looked at what Sarasota had done. We met with Pat Haley, one of her teachers, and we sat down with him, and we'd made a pragmatic decision. SolidWorks was the right decision. It was the right technical decision. It was also the right thing for our taxpayers in Manatee County. It was the best thing we could have done.
CAD system, CAD drawings, computer-aided drafting is absolutely worthless if you don't build what you design. What good is it? Fun. And that's what's important about bringing industry into the classroom. And some things that we can teach them is you design what you build. You don't build what you design. Now that might not make sense to you, but a little bit about me. I worked for Sun Hydraulics for 9 years in maintenance. I'm their electrician, commercial electric. I also have a cabinet shop. I do all of our mill work at Sun Hydraulics. Believe it or not, as a machine shop, we just built 100 and some Formica countertops. All our assembly stations and everything are laminate tops. I also make 5-piece cabinet doors. We have 5 shapers set up, and we supply other cabinet shops with doors. One thing though, it would be senseless for me to go out and sell miter doors when all my shop is geared to make a 5-piece door. Wouldn't make any sense at all. So what kind of doors do you think I push? I push the 5-piece door, cope and stick, and I never push the miter door because that's not what we make. It's very important in the classroom when you have the students designing projects that they're designing according to their manufacturing capabilities. And it doesn't matter whether it's manual machines, bandsaws, Bridgeport mills, wood lathes, whatever it is, or whether it's CNC. What's important is that when they design, it's something that they are able to manufacture, and it makes the whole process a lot more. As you'll see a little later, we have a video of some of the projects the students have done, and they're talking about those. Many schools are what I call CAD/CAM collectors. As I mentioned earlier, you go in and they have a traditional wood shop program, and it's a CAD/CAM wannabe. And the problem is that the instructors don't have the knowledge to run the CNC equipment, so they have it there and they call it a technical program, but yet everything that they're doing is being done on bandsaws and scroll saws and manual machinery. And they collect those machines and they just sit there. And I know many of you here have been into facilities, I mentioned before, and machines just sitting around not being used. I know of many machines in schools that haven't been started for a year, 2 years, and I'm sure you could point some of those out. They collect them up. One thing I want to mention that you need to get involved in is the purchasing of the equipment. And this is where the schools are really falling on their face. You need to buy industrial machines, not what I call concept toys. I'm going to give you an example. At Braden River, when Rich was over there, they had a Patriot mill there, and the spindle on it was a Dremel tool. Now, how many of you have been into manufacturing facilities throughout? How have you seen industrial machines with Dremel tool spindles on them? They're not there. So one thing is the students aren't really getting real life application. But what happened was they had this Dremel tool spindle and they kept burning the motor up. And then the company's charging them $350 for replacement. I think it was a Crest.
Yeah.
And they bought another one, they burn it up. They bought another one, they burn it up. Rich called me, he said, Russ, what can I do? I said, well, we're going to retrofit it. So they already spent $900 on spindles. So I went down, I looked at the machine, I said, well, we're going to put a Portacable 690 on there. Now, being in the wood business my whole life, cabinet business 25 years, I picked the 690 for a reason. Number one, it's cheap, cost $100. $100, brand spanking new. Number two, it brings the air in the top of the motor and blows it out the bottom to keep it cool, and also prevents dust from sucking up into the motor. If you have a motor that sucks air through it, guess where the dust's going? Right up into the motor, as with the Crest. Number three, the $100 Portacable will take a 1/2-inch collet, a 1/2-inch diameter bit. You can get a 1/4-inch collet, you can get a 3/8, 5/16. You can get a bushings to adapt it to anything. You can get extensions, okay? So those are some benefits. So I said, we're going to buy this $100 router. I ordered one. I went online to a company called K2 that I happen to know about, and we ordered a bracket to hold it for $46, something like that. And we mounted this router in there and hooked it up. And now, instead of using 1/8 inch and 1/4 inch tooling, he's running a 3/4 inch tooling to cut pockets and things. What do you think that does for your time? Okay, so then they began to use it. And as you'll see some of the products when you come up and check, they cut these coasters here. The kids drew them up in SolidWorks, modeled them, generated the tool paths in CamWorks. And these are coasters made out of Corian. They cut how many hundreds of them, Rich?
We cut 120 last year.
120 of those.
Would have cut more if we had got more countertops given to us.
That router run from the time we put it in, probably 5-6 hours a day, rest of the school year. The end of the year, Rich comes to me and says, "Hey, Russ, the router quit. It won't run." I said, "Well, take it off and bring it to me." He brings it to me. I open it up. The brushes were wore completely out. Now, I've been a cabinet maker 25 years. I bought my first personal machine new when I was 16 years old. I have never seen brushes wore out in one of those routers in all those years. My point for telling you that is not that the router failed, but that's how much they used it. I had a router there at the shop. I took the brushes out of it, a new one, put them in, gave it back to him, back down, put it in the machine. It's still running today. Guess how much that repair was? $6. So you see the importance of bringing industry into the classroom. When you're purchasing your equipment, it's really, really important that you try to get industrial machines. The other problem is the cost. I think that machine cost about 30 grand. For $30,000, I can buy a Shop Saber, it's called, is a brand. It has servo motors, it has ball screws, it has linear slides, it has a frequency spindle. Do you know what all that means? That means precision, industrial piece of equipment for the same money. Oh, and the other thing, the Patriot has a work envelope of about what?
13.5 inches by 8.5.
8.5 inches by 13 inches. Big as my sheet of paper here. The Shop Saber for the same 30,000 has a 4-foot by 8-foot working area. So what's going on? I could tell you numerous stories about the same kinds of equipment in comparison to industrial equipment. Well, the problem is the people that are making the purchases, they just don't know. And they have somebody coming in and saying, "Hey, you know, we sell this machine for schools and this, and look what it does." And they got a video, man, that thing's cutting like crazy, and it never works like that. So it's really important that you look for industrial equipment, and we'll talk a little more about it in a moment.
Okay. When Sun Hydraulics came to my rescue, we definitely needed a direction and plan. I could not spend the rest of my teaching career making these. I probably milled out 800 of these things, little dragsters, and we make them fast. We've been the top 10 in the United States in the last 5 years, 6 years actually, and then we've won the state championship 5 years in a row. I just can't make any more dragsters. I want to do something that's more fun. And so I went to Russ. I said, "We got to, girls don't like making dragsters. I don't understand why, but they don't like them." And so we wanted to get the girls involved. So we needed a direction and a plan. And Russ and I inventoried what we had. We looked at the machines, said, "Okay, we got to do some changing here." Now keep in mind, this inventory and what we have is an evolving plan. It's not a plan that we're going to stay today using a Techno router at all. We have to evolve the plan. We have to look at more things that we can do, and he kind of alluded to that in a few moments ago. Rusty had an arsenal, what I would call, he found what I call the Dead Sea Scrolls of woodworking. It was this 1952 Popular Mechanics book. It's so brittle, you have to turn the pages carefully. But it's all these awesome tools, awesome projects, and there's several of them laying right over here that we actually made from the book. Sometimes the best stuff is the old stuff. And he gave me the book and several other books that I use every day in my manufacturing classroom. So we went from CO2 dragsters to full-size sailboats. That's huge. I don't want to make one of anything. Last year, we had a student that came to me. He actually repeated one engineering class twice. And he said, "Mr. Platt, I don't want to go take choir. Please don't put me in choir. I want to come back." And I said, "But Nick, you already done the class." He goes, "That's okay. I want to be here. I'm on campus anyway." So he came back in, and for his capstone project, he wouldn't build a dragster if I put a gun to his head. But he said, "No, I want to build something big." And so I said, "Well, I don't want to build something. I want to build multiples." And so with SolidWorks and Russ's help, we actually designed and built 2 sailboats that we could actually take out and put in the water. It's kind of fun. Okay.
Some of the things that are missing are measurement skills. I don't know when you came in if you noticed, though, we had a PowerPoint running here, and it was entitled Precision Measurement. And it goes through every aspect of measurement. And it has worksheets there that show positions on micrometers. Then it has a page where the student would fill in what the measurement was. Same thing with rulers and squares and things like that. Being in the millwork business and maintenance for years, I can tell you that very few people know how to really read a tape measure or ruler, let alone micrometers, calipers, and those kinds of things. And I can also tell you that when it comes to measurement, the high schools are falling on their face. And we really need to work to develop a program to teach industrial measurement, I call it, in the classroom. Some things that you can do that'll make a big difference. You know, I go into classrooms and I see a poster of 15 guys jumping out of a helicopter all holding on together, and it says teamwork. How many of you have seen that before? And, you know, they're going to open the parachute or something and they're all going to do good. Okay, yay for that. But you know how much more beneficial would it be to have a poster there with all the decimal conversions on it? That every time that student walked by, he sees 1/8 equals 0.125. Or he sees that 5/16 equals 0.3125. See, and those things are important. You need to plaster your walls with measurement. A 1-inch ruler scale with all the fractions underneath it. All those kind of things are really important. And what will happen is the students will get dependent upon those posters that are throughout your classroom. And not only will they get dependent, their mind will start to focus in on those numbers unconsciously. And they will begin to apply those things in their work. So it's really important that you develop a program that's actually going to teach them precision measurement. If they would come to Sun Hydraulics and apply for a job, guess what the first thing they get to do is? Measure stuff. We give them a paper, some tape measure. They got to know how to read measurements. They got to know how to convert fractions to decimals. And those things are really missing in the classroom today. The other thing, before I put this presentation together, I went and I talked to our HR service at Sun Hydraulics. And I said, Greg, I said, what's missing for young people coming out of high school, coming in and applying for a job? And he said, Russ, I'll write those things down for you. And the things that was missing is they don't even know how to conduct an interview. He said they do not know how to sell themselves. He said they don't know how to tell me about their skills and their experiences. And the other thing that he said was their dress. They don't know how to dress for an interview. Now, we've got a PowerPoint that we put together. Kirsten Riegel, who is the director of Sun Hydraulics HR department, has put together a PowerPoint entitled How to Get a Job and Keep a Job. Things that we're looking for. And we can make that available to you.
We have some.
And
we have some here.
Yeah. And so those are some really, really important things to do. But what can you do as a educator to help the students with that process? How about this? Do kids like to play games with each other? How about we have an HR department in the classroom and we have 5 people coming in for an interview. And they have specific criteria set up. This is some things we're working on at Southeast. So these students are the HR. They've got students coming in for an interview. We have the rest of the class sitting here evaluating the process. And then we say to the class, who got the job? And the class, of course, can take notes during the process. Who got the job? Well, Billy did. Well, I think Jody did. Why? Well, Billy wasn't dressed very good, but Jody really spoke good. Do you see what that's going to do? Now, you have to control that. But it's going to really challenge the students' thinking about the job interview process. But you as an educator are going to have to do your homework. And that's where industry comes in. How about you come over to Sun Hydraulics where I work and you say to Kirsten or Greg, hey, we want to teach the kids job interview skills. Would you guys come over and interview some students for us? We're going to post some jobs and we want them to come over and apply. Would you help us to learn to set that up? What do you think they're going to do? They're going to come over and they're going to set it up and they're going to help you. And what are you really doing? You're creating real life situations that these students are going to face every single day. Next, materials and supplies. You know, something that amazes me about the high school programs, they got some good equipment. I mean, they'll spend 30 grand on a laser, and that's great, and that laser's sitting there, but they ain't got nothing to cut. How many of you experienced that one? Material. They hardly ever allot money for material. And that's where your partners in business can come in. You go to the cabinet shops, you get to know the cabinet guys, you get to know the plastic guys, you get to know the metal people, and you glean from their scraps. In our small shop, cabinet shop, 1,000 square feet, I have 2 people that work for me, part-time. We produce enough scrap to supply Braden River High School with wood for the last 3 years. Just in scrap. Because in the millwork business, scrap's about 25% of your raw material. That's a lot of stuff. And the problem is, it accumulates so fast. So industry is going to be your best source for material. But again, I say you need to approach industry with an open mind and humility, not that they owe you the material, but they're giving something back to the community. And what's really important is, as you'll see in the video, you let them know that their material contributed to the community. Very, very important. Hey, Sun Hydraulics, that aluminum you gave us, we turned it into this, and this is what we did with it. That's great. And companies like that a lot. Tooling. Tooling's a major problem. Tooling is a big problem. First time I was with Rich and he was cutting some stuff on the mill and he called me. And I drove down there and the place is full of smoke and I'm looking and he's got a 4-flute metal cutting end mill in a router that's turning 20,000 RPMs, 25, and it ain't doing nothing. And I looked at that and I said, you got the wrong cutter. I do not. It's got 4 blades on it. It should cut that easy. And I said, well, 4 blades are good, but you probably only need 2. So industry can really help you with your tooling issues. Tooling is everything. For some reason, schools and places, they want to buy cheap garbage tooling. Oh, wow, there's a router bit for $5. Get me 4 of those. And they put it in the machine and it cuts for 15 minutes and guess what? It's junk. So these are some real areas. Your tooling is as important or more important than your machine. Now I brought with me a cutter from Southeast Tool, and I brought this for a reason. I want to pass this around. I want you to look at this. And I want to tell you about this cutter. For students in the school and teachers doing CNC, what do you think the biggest challenge for them is going to be? Anybody? I'm going to tell you what it is. It's holding the workpiece so you can machine it. How many of you have had problems holding your workpiece? I'm going to tell you some things to help you with that. Number one, your tooling plays a big part of that. When Richard's running that 4-flute cutter, what do you think it was doing to his fixture? Because it wasn't cutting. So it's pushing it, it's loading it, it's doing all those things. What I have here is a 2-flute spiral downcut bit, solid carbide. This bit isn't cheap, but it isn't either expensive. This bit's 30 bucks. All right? Now, in my shop, I can put this in our router, and I can cut plywood with it. And I want you to guess how many inches of plywood I can cut, 3/4 inch thick, before this tool gets dull. Anybody want to take a guess? 1,000, you think? How about 50,000? Last bit I put in the machine, I cut 50,000 inches of plywood. Now you're probably sitting there saying, this guy's some kind of nut, counting the inches of plywood that his router runs. But I just happened to be cutting the same part out, and I knew the circumference of it, and I cut out about 65 or 70 of those parts, and I just kind of did the math and figured it out, and I said, wow, that's great. When I first started using these years ago, I could put the tool in, and I got very little life out of it. I might cut 3 or 4 sheets of plywood, and that baby's so dull it wouldn't cut anything. And then I started experimenting and started learning and training myself. The feed rate was too low. Now, what you think is the slower you go, the better it cuts, right? No, not at all. You got to have balance. Balance between the chip load and the RPM of the tool and the depth of cut. And once I started speeding my feed up on my machine, I'm cutting now 250 inches a minute with this bit. So you see, tooling is everything. Where are you going to learn all this? How many of you believe it's in a book? Well, it's probably in a book. How many of you know how to get it out of the book and up here? That's where industry comes into play. Now, I'll tell you something, a little secret about people. If there's one thing they like to do, they like to talk about themselves. And even busy people, if you can get them to stand still for a minute and start talking about themselves, guess what they'll do? They'll tell you everything you want to know about themselves. So when I wanted to know about tooling, I went over to this shop where they run a big CNC router to the operator, and I said, man, you're good, man. I look at the stuff you're cutting. How'd you learn all this stuff? And he starts talking about himself and telling me. I said, you think you could tell me some stuff? I can't believe how much knowledge you have. And I mean, he just told me all kinds of stuff I wanted to hear. How hard was it to extract that information? It's pretty easy. My point is that industry in the classroom is where you need to go to learn about tooling. And tooling is going to determine your project. Let me give you another example. How many of you seen the mirror that the kids made? The mirrors. The first mirror we made, the kids made, they carved it out, and I went down and looked at it. And I looked at it, and it looked like a washboard. How many know the washboard? That's back when I was a kid. I said, it'll take you a week to sand that thing. Well, what can we do, Mr. Bowen? What can we do? I said, well, what's your percentage of step over on your tool? Yeah, the percentage of step over like 40%. So he's using an 1/8 inch tool. That means he's getting a 1/16 inch. I said, let's change that down to about 8%, 4%. So we changed that step over to 4%. And when that mirror finished cutting, the kids took a little piece of hand sandpaper and went like this. And guess what? They were finished. Where are you going to learn that? It ain't in a book. You have to go to industry to be able to learn that. Tooling's important. CNC shop and equipment repair, and we talked about that a little bit. When your machines break down, go to industry. Sun Hydraulics has about probably 20 maintenance guys there, 25. And we specialize in everything from CNC all the way down to fixing landscape lights on the building. If you have a problem with your machine, guess who's able to fix it? Or walk you through it, or tell you what to look for. And that's people in industry. You're going to call a service tech? How many of you are educators, teachers? Okay, I had a question for you, and I want you to answer. How long does it take to get a maintenance person to come in and look at one of your broken machines? Like tomorrow, today, week, month? You guys are like hanging your heads down. Pretty hard to do. It's like pulling teeth out of a chicken, isn't it? They don't even have teeth. So what do? You take the incentive to learn to build relationship with industry, and they'll send somebody down there to help you out. Because make no mistake about it, if there's one thing in America I can say, the people of America, they care about the youth and they care about education, and they will do it. Existing equipment. This is an important one. And it goes back to what I said earlier about designing what you build. And many of you have CNC equipment, and many schools don't. But that doesn't mean that the students can't design and build. Everything that you see on this table that our students have built can be built with hand tools. Everything here can be built with hand tools. And so you need to learn to optimize the equipment that you have and learn to use it and design your projects around the tooling, the equipment, the materials, and the supplies that you have available to you. And as Rich said, that's not locked in. You go from there and you build an arsenal of equipment and tools. And that's where I was talking about those hoarders. If you get your program working with the equipment that you have on hand, then and only then are you in a position to go to the administration and say, look, we're using everything we got. We're busting at the seams here. We need some equipment. Why can't you pull it from over there? They're not using it. We just had that happen the other day. We was talking to someone, I won't mention names, and said, hey, they got all these machines. They're just sitting there. Call down there and ask them if they're using them. They called down there and they said, no, we're not using them. They said, okay, we'll be over to get them. We're taking them over to Southeast. You can do the same thing. Now, everybody's not going to be happy about that, but they'll get over it. But what's really important is when you get them, you put them to work. But build and design according to your ability to manufacture the product. The next thing is internship instruction. You can really help the students by getting involved into industry. A lot of students have come and worked in my shop for me, doing things that they could do. A little bit of part-time, maybe sanding, maybe doing some stuff to help them out. But they've also brought their major projects to our shop and worked on them that they did not have the capability to do at the high school. One project in particular that I remember is when they built a car cockpit for the
F1 in schools.
F1. And it had touch screens in it and this and that, but they didn't have the facility to do the sanding and the body work and those kinds of things. So they brought it and we set up some air sanders and the students sanded it and they did the work, and we videoed it because we didn't want anybody to say the students didn't do the work. And they actually won. What they place there?
Well, we won first in the U.S.
First in the U.S.
And the big thing that we got out of that award was that we got the best manufacturing in the U.S.
Yeah, and couldn't have done that without industry, because after they did all the body work and things in our shop, they loaded up and they went down to the local paint shop and said, hey, you know, we got this thing. You think you could help us paint it? And you know what they did? They said no, right? No, they said, absolutely, we want to be a part of that. And that's important. I mentioned earlier about equipment purchases. No more toys. And the design and the fabrication on the bigger machines is tremendous. The speed that they have in comparison to the toys. One thing I would suggest, how many of you have been to trade shows? Trade shows are the most awesome place to go and learn that there is, if you go to the right trade shows. How many of you have ever been to the AWF in Atlanta? The AWF is 39 miles, if you walk the whole show, of supplies, woodworking, machinery, and equipment. Most all major manufacturers of industrial machinery have an education program. And that's what I can't understand. I can't understand why the schools are buying this junk when they could buy good stuff at a cheaper price. Doesn't make any sense. That's where you all, as teachers, who are going to be getting new equipment, you know when those grants are coming in, you know when those funds are coming available, you got to do your homework, and you have to fight. You got to say, no, I don't want that. I want this, and it's cheaper. It's better. And trade shows will really help you to be prepared to sell for the better equipment in your programs. We looked at the capabilities of the machines and the tools, and we want to talk about repurposing the resources. How many of you had heard the term, well, that's just an old wood shop, about school shops? No, it's not just an old wood shop. We're going to repurpose those resources, and we're going to turn that old wood shop into a manufacturing facility. Because it's not always practical to do everything by CNC. And how many of you think that everything that's manufactured at Sun Hydraulics is done with CNC and automation? No, it's not. We have deburr tables that go from here to that wall with people sitting on them, deburring parts every day, because our CNC equipment just can't get that job done. So there's lots of value in traditional equipment. And there's lots of things that can be made with traditional equipment that it's not practical to make on a CNC machine. 5-piece doors, for example, I mentioned earlier. We have 5 shapers set up. One shaper does a cope, one shaper does the rail, one shaper raises the panel, and one shaper does the edge of the door. It takes us 1 minute and about 40 seconds to machine all the parts for one raised panel door after the material's cut to size. How long do you think that'd take on a CNC router? It'd take a long time, because you have to put the single piece on a fixture, the router comes in and cuts the tenon, it goes back, you got to change the bit, it comes back and cuts the rail. My point is that everything, it can't be done automatically. And you need to teach the students how to use hand tools. I've had students working with them that didn't know how to use a screwdriver. I'm not making this up. But they could draw in SolidWorks like you wouldn't believe. So you see, it's really important to combine all of these things together: machine tools, hand tools, and you need to repurpose your resources. Start looking at what's available in your community, what's available for you, what kind of materials you have, and repurpose those into your program. Wood versus metal. How many of you work with metal in school? Metal's a lot harder to work with, and that's why we use wood. The processes are very similar. Wood's a lot cheaper than metal. I don't know if you know much about metal, but right now copper's selling for scrap about $3 a pound. Steel's about 10 cents. Metal's very expensive. Wood, on the other hand, is more affordable, more readily available. So there's some things to think about. Drops and nothing to waste. We don't waste anything at the school. We make something out of everything. We have kids making little name things. I have my business cards here, and
You have them up here.
here they are. Little name plate made out of wood. I mean, you don't get much smaller piece of wood than that. Kids love to make this stuff. So there's lots of things you can do. There's lots of resources. The point in repurposing your resources is to use what's available to you. If you have a small limited supply of material and you got 30 kids, you probably want to look at more of those smaller types of projects versus larger projects. You need a balanced approach, as I mentioned earlier. Not all CNC. And that's really important. Balance it out. Teach them. You want to do CNC? Before you do CNC, you really need to learn to read the ruler. You really need to be able to drive a nail with a hammer or a screw with a screwdriver. Very important, because with the CNC, they have to build fixtures to hold their work. So those things are real important, and you can learn a lot of that from industry. And I mentioned earlier, you emphasize the projects to the tooling that you have available to you. Very, very important. You want to get students totally engaged, totally excited about what they're doing. And that's why, and we're going to talk about project here, I think it's coming up pretty quick, of how students can get engaged and excited. They like to see progress just like we do. And they like to hear an attaboy once in a while. And that's important. And Rich is going to pick up here, and I think this is a slide with the video.
It's probably the next one.
Probably next one.
Okay,
so he'll talk about engagement a little more.
One of the things that, I'm sure you guys have been beat up about is rigor and relevance. When I sit there and I think about that term, I'm like, rigor and relevance. And I think it's inverse. I think it should be relevance with real rigor. You get a kid that's going from making a dragster to making a ukulele to making, some of the stuff you see out here on the table, and all of a sudden, the rigor happens. Because what they're making is something they can take home. Mom, look what I made. I sold 3 of these on eBay. Isn't it cool? And they get real excited about it. Then the rigor really kicks in. And after they have doing something that they totally enjoy. Every day in my dadgum classroom, these knuckleheads come in here and grab my ukulele and they start playing it. And after a while, it's I used to get mad at them, but after a while, it's just, wait a minute, this is kind of inspiring the kids because that's what they want to make. That's what they want to have fun with. And having an unlimited encyclopedia of knowledge is so critical. When we embarked on building the sailboats, I had to find a 4-foot by 10-foot sheet of plywood of a certain grade. Hey, Russ, where are we going to find this? I can't even find it with the boat suppliers. I don't know. Let me make a few calls. And then by him doing that, I got the resources I needed for my kids to build these boats. And it was a lot of fun because, the kids are coming up, man, we've got African mahogany.
Tell them how much a sheet.
Oh, the 4-foot, this is crazy. The 4-foot by 10-foot sheet of Luan plywood, 1/4-inch thick, was $27 a sheet. And we had 6 sheets, 2 sailboats. It was awesome. And having someone that's a phone call away, Rusty and I probably talk 5 or 6 times a day, about that project or that project and getting resources. And what's funny is he's not the only one that calls me. I got other people. I got guys showing up with trucks fulls of cabinets where they're doing demos and say, hey, Platt, can you cut this mahogany down or this walnut down and do something? Yeah, bring it in. And so having those resources is cool. And he's only 5 minutes away from my school. I try to find people in the local vicinity. Son also has something that we as teachers can't get our hands on. Finding that 4-foot by 10-foot sheet of plywood was critical. Another thing that I noticed by going over to Russ's shop and watching how he does things, I said, man, all these screws you got square heads on them. They don't ever break. And so I've switched from Phillips head screws to going to Robinson head screws, the little square ones. Made a huge difference in how our stuff comes together. So having that supplier network was critical. And then unlimited enthusiasm for design and manufacturing. When his people, his executives, see what we're doing, they will do anything to help us. And it's crazy to see what happens with that enthusiasm from our partners like Sun Hydraulics. The International Baccalaureate Program is a program we're real proud of in Manatee County. Obviously, we had kids go to MIT. We had one of our kids do these internships, and he wound up going to England. He's a graduate of our school. He was on our F1 team. He went to England. He interned with McLaren Racing. It don't get any better than that. You get to go, you like cars, and you get to go work with McLaren Racing and work on their F1 cars. That's pretty cool. But this training that we have with Son is vitally important. When those kids come in and they sit down for their interviews, like one of my students that worked with him last year, Nick Brettweiser, who built the sailboats, he worked with Russ all through the spring when he left my place, because he wanted the real world experience.
Building a CNC router.
And he built his own CNC router, that's true, and sailboats and gumball machines, and it goes on and on. But one of the things that was cool about that experience, when he got his scholarship, he got a full ride to Florida Institute of Technology, FIT. And it was because when he sat down and went into their engineering facility and said, "Oh wow, I've used that router. Oh, I know how to use that one. You know, what are you using for fixturing? How are you making your fixture? Oh, you got a Bridgeport? We have a Lagun." He's able to talk about those kinds of things with relevancy. Now, what I want to show you right now is the effects of what's happening. Our plan was to get our students to design and making fun and totally engaging projects. Last year, I'm not trying to brag, but this happened. It actually caused me a little bit of a problem. But last year, out of 3 tech teachers in my program, 352 sophomores, juniors, and seniors choiced into my classes. It's because of this stuff. It's not because of Mr. Platt, he's crazy anyway, but it's because of this stuff. You take home a burled walnut $80 mirror that's got a stainless steel glass in. Mom, look what we made. And you got girls doing that. It's pretty awesome to see that happening. And what our projects were, we started with the hand mirrors, we started with the Corian coasters, the jewelry boxes, trophies, and plaques. You know, our seniors are now going, "Hey, Mr. Platt, let's do that fundraiser where we go and laser engrave the diplomas and sell them for $50, put it back in our program." I said, "I think that's a great idea."
Gumball machine.
Yeah, and the gumball machines are real exciting. I just can't keep any dang gumballs in my class anymore. The other thing that we did last year was we designed desk clocks, we designed nameplates. The lock boxes was a freshman project we started kids out on, where they got to learn how to do mates in SolidWorks. You got 31 parts in this little box, and they all came out the same. And I actually didn't have a tutorial on this. What we did was I put the drawings up, like Russ said, challenging Platt, put the drawings up on the wall from my original box that I prototyped. Kids get after it.
No metal fasteners.
And they go out with no fasteners, nothing. It's all made out of wood. And they would come up with their scales and rulers, and they start measuring this thing out. And what really blew me away was how accurate they were once they really started getting the process down, because they couldn't make a mate. Uh-oh, got to fix my part. So they go back and fix it. So these are the things we did. It's a lot of fun. We had a great time with it. My wife got mad at me because I never would come home at night, it seems like, because we just stayed up at school making stuff all the time. Now, one of these projects, let me see. Okay, here you go. We do have a video we want to show you if you won't run out of time.
You know, we need to teach about the measurement tools and the opportunities. And he touched on that a little bit just now with Nick. He knew the language. I've given interviews. How many of you have given interviews before? You know what that person knows pretty quick, don't you? These guys have been doing it for years. They know. You interview a student and he can come in and he can say, "Oh yes, I can read calipers. Oh yes, I do know what micrometers are. Oh yes, I do understand milling and feeds and speeds and tool and chip load and those kinds of things." That is a big opportunity for them. It helps tremendous. You're creating opportunities for them by teaching them even though they don't know. It teaches standard shop tools, to use the standard shop tools. That's important. At Sun Hydraulics, when someone comes in for an application and they're going to test their measuring skills, what do you think they give them to use? Digital? No. Manual. So you need to teach these things, and you need to challenge the students, as Mr. Platt has challenged the students with this lockbox. And one other thing that you have to do is you have to build it first. You can't wait till you're in the classroom and start trying to design the project. We sat at my desk and designed this thing, and we've actually changed the design some to make it even better. But you have to do it first, and then you're able to challenge the students with the project. Simple fixtures, design and fabrication. Fixtures are everything. You need to teach them to design with fixturing in mind. When we build custom cabinetry and we build stuff in $1 million, $2 million, $3 million houses, I always design our products with installation in mind. How many of you have ever seen somebody build something and then they couldn't get it through the door? Well, I got news for you. You're not alone. When I was in my 20s, I built a whole kitchen and none of the cabinets would go in the house. How do you think that felt? It had a 30-inch door in the house. So design and fixturing is really important, little things. For example, how many of you know what a roundover tool is for rounding over wood with a router a little bit? Just the slightest little roundover makes your project so much nicer. We've actually designed a little router table. We haven't built it yet. It's going to be at Southeast Tool. It's a piece of plywood with Formica on it. It has a Craftsman $15 router you can buy at a yard sale mounted underneath it. And then it has the bit set. Then we have a little bracket comes up and goes down over top of the bit, about this big around, and a clear plexiglass so you can see. No way can you get a finger in it unless you take and smash the finger and stick it in there. But that stays set up all the time, and every time a student burns their little name on their thing, they can go over there to this little thing and zip it around there and round the edge over. Very simple. It teaches them about the process of fixturing. How about drilling holes? We would take a piece of plywood and put sticks underneath the bottom so it fit the drill press table. And then we would screw other sticks in place so that the students could come over, lay their piece of wood in there, and drill the hole in the same spot every single time, thousands of holes. So fixturing, design, and fabrication are really important, but what's really important is when you sit with a class and you say, we got to drill 2,000 of these holes in these cars. Anybody got any ideas how we're going to do it? And they'll throw some ideas out there. And you say, I've been thinking about it a while. What do you guys think of this? You have to engage them. You have to involve them. You have to respect them and listen, not just shoot them down. And when they come up with an idea that's bogus, you say, well, that might work, but this might even work better. Don't hurt their feelings. Boy, that's dumb. How have you seen somebody do that kind of stuff? Well, that's stupid. How dumb can you get? Well, how long do you think they want to learn in that class? Cabinet top drops for materials. Use on hydraulic supplier network. Rich talked about those things a little bit. Provide the right CNC cutters. We talked about that. That's one of the most important things that you can do. And, guys, myself, I'm just a phone call or an email away. If you want to know, you know something, you want to get involved with the things we're doing, get my card, shoot me an email. If I can't answer your question, I probably know somebody can. I taught them how to spray and finish. I went there, and their finishing was atrocious. I said, what'd you do, paint over top of the sandpaper? And we began to work with the process and sand it with 80 grit, 120, 180, 220, put a clear coat on, scuff it, those things. These are the things that you're going to learn from industry. Getting out in the community, talking to people. But to make that work, you have to be friends with the people in the industry. You got to befriend them. You got to get to know them. And that's what's really important. You have to build relationships for a common purpose. Came into the classroom, challenged them to improve design and the products that we're building. You see what we've done? And these are old products. These are last year's products. These jewelry boxes, how many of you have seen these? These are dovetailed. Did you know these aren't made on CNC? They only lasered the name. The velvet inside, they folded the fabric over on cardboard and glued it in with, what do you think they glued it in with? Contact cement. See, they didn't know that. They're down there trying to glue it in there with Elmer's glue. I said, Rich, what are you doing? You're going to drive them poor kids crazy. Got a little bit of contact cement in a squeeze bottle, put it on the cardboard, brush it on, a little bit on the velvet, fold it over, sticks instantly, done. Industry can help tremendous in the classroom. All right, Rich, here you go.
What I want to show you right here is a project that we did for community service. It had to do with, which kind of hits home with me. I'm a grandfather, just got me a new grandson, and my son is a professional baseball player, so I have to raise his child. So this is with me. So this program was a video about how we helped foster care parents in a program called GAP, Grandparents as Parents. I want to show you a video. I didn't know it was being done until the very last minute. My kids came in and showed me the actual video that they were producing. They actually did this for competition. So if I can get this thing to replay itself here, if I can find what I'm looking at, a little bit blind here, so bear with me. Set my glasses down. Russ, what do I do with them? Wait a minute. Hold on a second here. Sorry about that. In this video, we're actually using the SolidWorks to your project. Here, I'll turn this up.
It's on 7, I think.
This past weekend, the design, technology, and engineering students at Southeast High School were given a unique project opportunity. We were told to design cars for little children in the GAP program, which is a foster care, and it stands for Grandparents as Parents. We first had to take the idea of whatever type of design we wanted and create that in SolidWorks. And we made that design come to life into a 3D model. And from there, it went to CamWorks, where we designed the tool paths that our mill would then be using to create the car out of a 2x4 stud. And you see your original idea morph into an actual tangible thing. And it's a really crazy process to see occur in front of you. And so the end product, you have a milled out basic car. And then what we did was we took about 50 to 100 of these milled out cars over to Hale Middle School. And the students then had the opportunity to take paint and a variety of things and paint the cars in any way they wanted to design them. And it was just one booth out of a variety of booths. There were robots there for the kids, even Santa showed up, there was performances and gifts, and it was a really good opportunity because you could tell that all of the younger children were so appreciative of what we've done, something so simple that really didn't take a lot of time in milling out. It was really a labor of love, and to see so much appreciation for something like that was really impactful upon the student body as a whole, and you could definitely see that. And I think what made this project unique and different from all the other ones we're assigned in school is that most teachers assign projects with the intent of getting a grade from the end result. But this was a little different. We knew where the cars were going and how much of an impact they were going to have on these foster children. And I think it made everyone in the entire student body as a whole value the project because we were giving back to the community. And we were still learning. We were figuring out how to design in SolidWorks. We were figuring out how to make tool paths in CamWorks and how to use the mill. And it was a great experience overall. And I hope we go back next year at Hale because I think as morally we gained a lot and intellectually we did as well.
Techno routers, a small investment with a big return.
One of the things that was interesting after we did this video was that the kids, it was right before winter break, and it was a Friday, and we were leaving to go, home and do all that. Well, I get out of school at 3 o'clock by contract, and I'm looking at 4 o'clock and going, hey, I'm ready to go home. I'm ready to start my vacation. And that girl and 2 other girls were sitting there going, Mr. Platt, we got to mill out 3, 4 more. And I'm like, why? And she says, well, we're using these for, gifts for our friends and all that kind of stuff. And one of the little girls, I say little girl, she's a junior, she designed and made this little 18-wheeler truck. And she's a tough girl. She's a basketball player. She hardly says 3 things in class. She's got this real rough, demeanor about her. And she pulled me aside. She said, Mr. Platt, I want you to understand something. I didn't know what I wanted to do in my life. And I thought this engineering stuff was a bunch of crap, and I didn't want to take this class. But you've changed, what we're learning in here has changed my life. Not me, but what we're learning. Using SolidWorks, like Russ is talking about, designing and building fixtures. She's the mother hen. She walks into the manufacturing room, says, all right, guys, here's how you touch it off. Let's get it ready. Okay, tighten this down. And she's over there showing how the kids how to sand cars and everything. Another girl made 6 of these projects for 6 of these cars for their kids. And it was really exciting to see these girls embrace this. We're making trucks. and they're excited about it. The boys have long since blew out of the lab, and these kids are still in there, these girls making their projects. Well, these are instances where the school did not have the machinery and equipment to do this. And what I did, oh, I'm sorry, this is your slide, Russ.
That's all right.
So,
Rich come to me one day. Southeast High School only has one little CNC mill
at the time.
And he says, we're going to buy this kit. And we had a big fight. You know, in all the years I've known him, we never had a crossword. We had a knockdown, drag-out argument. And I said, you buy that kit and we're done. We're finished. Because I says, they will laugh you and scorn you to end. He was looking at buying this kit because they had nothing. It was plywood cut out, and you buy it online. And it come with some stepper motors and some stuff, and you put it together, you make a router. And the drive system on it was bicycle sprocket chain. How accurate do you think that is? I said, Rich, hold on a minute. Back up a minute. So the next day we got back together, and I said, you still on that? I said, I ain't doing it. I said, I will help you. We will build a 4x8 CNC router. The students will do it. He said, really, will you help us? I said, sure, I'll help you. Sun Hydraulics will help you. So then he said, how much it's going to cost? I said, let me look at some numbers. So I started figuring it all out, and I put it all together. I said, about $5,000. So he's talking to, and the Boys and Girls Club donated $3,700 to the program. And then we talked to some other people in the community. They donated some program and everything. So you see a CNC router there on the right that's in our shop. The kids come over and measured that up. And they modeled it, as you see on the left, in SolidWorks. And I said, okay, we're going to start with the frame. They modeled the frame. They emailed me the drawing, said, Mr. Bowling, check it out. And I looked it over, and I sent it back and said, sorry, can't build that frame. Fix the drawing. They emailed me back, what's wrong with it? I said, figure it out. It ain't right. Next day, I got another drawing. I opened it up, I looked at it, I sent it back. I said, sorry, look at the measurements on the cross pieces. They drew it, and this took a week and a half. 2 weeks?
Week and a half.
Sent me another drawing, I opened it up. Then I had to type up some notes. I sent it back, and they sent me another drawing. I said, okay, we're ready to go. And I cut the metal, and we delivered the frame to the school yesterday. And the kids put it in place.
It was kind of neat. You had 8 boys, 2 in the front, 2 in the back, 4 in the middle, carrying this big steel frame up to the building, tipping it over, and putting it into the lab. And we had a parent night last night at our school, and the parents were all hovering around looking at this machine that the kids are actually designing and building with our industry partners' help. That's pretty cool.
So now they're going to paint it up. Next step in the process is these side rails here. I don't know if I got a pointer. It don't work. These side rails here is the next part of the process right here. I'm going to cut those 2 angles.
Right there.
And I'm going to send them down to the school. And guess what the kids are going to do? They're going to lay those holes out and get everything in place, and then I'm going to go down and inspect it. And then we're going to set up a drill press, and they're going to drill the holes. And they're going to get them mounted on the machine. Then we're going to do the same process with the bridge and the things. And the motor brackets, they're going to draw those up. And then I'm going to send them over to a friend who has a laser. He's going to laser cut them out, 1/4-inch plate steel. And we're going to build this machine. Machine will be stepper motor based with gearboxes. It'll be driven by Mach 3. How many are familiar with Mach 3? It's machine design drive software. Very inexpensive, about $150, and it will. It's a step and direction. Does anybody know what that is? Pulse. So stepper motors work with a pulse, and for example, a G-code program will put out as much as 50,000 pulses a second to tell that motor which way to go. So the kids are going to learn all this stuff. So they build this machine. We build the controller, use a breakout board, all the different components. They put it all together. What do you think is going to happen when the machine breaks down? They're going to have to beg for the school to send technicians over to fix it? They have to go out in the community and get industry to fix it? No. they're going to say, hey, look those SolidWorks drawings up of that schematic of that machine we built.
One of the things that happened was Doug Wagner, our adult career tech ed director in Manatee County. We had this techno. We're making these gumball machines and selling them on eBay. Well, the first day of school, the kids came in. Nick Brewis, my senior from last year, came in. We already had the fixture set up on the machine because we left it the way it was before school started. He came in the first day of school, milled out, 4 or 5 of these things. And it ran until April, and then one of the servos went out in our Techno Patriot. And I'm like, this thing just went out of warranty. Oh, man. So I picked up the phone, called Techno, and I said, what is it going to cost for me to get a Z servo? And they go, $530. And I about, fell on my, out of my chair, going, $530. Well, right after that, we smoked the Y servo. And so I called Doug and I said, got a problem. And he goes, what? And I told him about the price of the parts. He goes, you got to be kidding me, man. I said, no, man, I'm dead serious. He said, how many of these things have I bought? I said, you bought 5 of them, 5 Techno routers. And he came over one day and we're looking at it. He said, why don't you build one? And so I said, well, let me talk to Bowling. And I brought the kid over there, and Rusty about chewed my left leg off. And then we started looking at actually building one. And the big thing was, you smoke a servo, $530. You smoke a NEMA 23 or a NEMA 34, you're talking $50. And so, and you can buy them anywhere. You can buy them on eBay, buy them in China, buy them on Amazon. You can buy any of these parts everywhere. And the software is universally out there. You can download Mach 3 right now and use it as a G-code interpreter to interpret all your G-code that you write. It's free. You can go up to 500 lines. And it doesn't require any special, FNUC controller or anything like that. It's FNUC compliant. So everything the kids can make and own and they can control. And it's cheap. It's very inexpensive.
Very, very good. But the real thing is, you have to go out in the community, in the industry, and find people that know a little bit of something about it. Mr. Platt could not build this CNC router without myself, Sun Hydraulics, people like us. Which and then, in turn, we know people in the community, E&M Metals, welded the frame all up and everything. And when we got the frame to the school, what do you think the first thing we told them to do, the kids? Check that frame against your print, make sure it's right. They're out there with tape measures. It's perfect, it's right, it's good. Of course, we knew it's good, but, so. Rich?
Yeah, one of the things that's really helped me as a tech ed teacher, and it's helped us with having industry in the classroom, is design and manufacturing class is extremely busy, a lot going on every minute. I had a fellow teacher last year come into my classroom. He's really kind of fastidious kind of guy. And he walks in, man, it's so dirty in here. I'm like, yeah, man, we make stuff. We're not running some photo lab over in your classroom. We make stuff. And we have fiberglass and epoxy and sawdust and tools and all that. It's extremely busy. And you got to watch them like a hog. They try to cut their finger off or something. So what I did is I had to stop, and also you reteach and you reteach and you reteach and you reteach again. And I'm not talking about special kids with learning disabilities. I'm talking about smart kids. Because some of this stuff is complex. You got to sit down and look. When you're doing your tool path, you can't do a 40% step over. You're making a dragster. So you have to go and repeat stuff. And so I took a clue from one of Melissa's former teachers. He just retired, Pat Haley. He makes great videos. Anybody been on the Cuda Country website? It's an awesome website. Go check it out. CudaCountry.net, I think is the name of the site. I have a link to it here. Well, my website's richardplatt.net/training/3D model. I got 4 video tutorials on making the dragsters, nameplate project, and to making the hand mirrors and the toy trucks that you see over here. And on that website, there's probably for each project at least 180 plus videos. There's small little 60-minute, 60-second, 60-second to about 3-minute long videos on each concept I teach. So for those that are like me, that are attention deficit driven, you can actually get the concepts down and repeat them. And what's really cool is I cheat. I use it as one of my declared, interventions for my, learning disabled kids. Like, well, I do a video tutorial for them. How easy can it get? And it's really helped me out a lot, and especially for my English language learners. They'll just turn the sound off. I had a bunch of Cuban kids last year. Just turn the sound off and just repeat it back and forth. I said, you guys getting this? See? Okay, works for me, man. So that's real helpful. And the thing I'm doing now is I host these sites. I host these on my website, richardplatt.net. I'm going to move to YouTube base. The reason I want to go to YouTube base is they have a better compression algorithm for compressing videos. And plus, I get to use Google AdSense for my website, help pay for some of this, make a little extra coin, help pay for some of my efforts that I'm doing. Currently, these are the projects that I have online right now. The next ones we're going to be doing, I watch real close what my partner, Pat Haley's doing. And Pat's an awesome guy if you get a chance to meet him. I'm going more towards things that are different than what Pat's doing. He does a lot of, I don't want to say middle school based type stuff because we use it in high school as well. But I want to go more towards what I can appeal to the ladies. I want girls in my classroom. Because I get the girls, I get the guys. So it kind of works out that way. And one of the big ones my junior girls want is they want to make sunglasses. I do too. So, and it's a high selling item. We can sell those for $100 a pop or better. We also are going to start making wooden wristwatches. That's the beauty of having a partner like Russ and his company and others is they give me really nice wood. I mean, if you saw the maple mirror over there, that's really nice wood. You can't go down to Home Depot or Lowe's and buy that kind of stuff. You have to go find a shop that specializes in that. And it was really sad the first time I came over to Russ's place. I said, "What are you doing with this big tub of wood you got over here? Big, trash can of wood." "Oh, we're just going to take it out and burn it." And I'm like, "No, don't do that. I can use this stuff." And he has a name for me. I can't repeat in here about how I like wood, but I take that stuff and I cut it up. And I'm such a wood fanatic now that I started doing it. Anybody ever heard of the term lignum vitae? It's actually grown here in Florida. Y'all know what lignum vitae is? It's the hardest wood in the world. I mean, they use it on the Nautilus nuclear submarine as bearings. It's amazing wood. It's incredibly beautiful. I have an uncle that lives back in Texas. He's now sending me Texas red mesquite, which I can't get here in Florida. So we're looking at things we can make high dollar, high volume products. And the cool thing about it is with Russ's help and Son's help, and they really bought into this, and the school has been wonderful about it. And I think they've had the same vision. Doug's probably talked to Melissa about it, is that we want to create a manufacturing enterprise. We want to pay these kids for what they do. We want to get them being Russ and I call it the organ grinder or the dancing monkey. Most of us are dancing monkeys. I want the kids to learn how to be the organ grinder, where they basically come up with a product. Maybe it's a wooden sunglass or the watch. They market the product, they build the product, they produce the products, not one or two, 10s, 20s, 30s, and then we put them out on a website called etsy.com where you can create our own Etsy stores, it's called. And I told the kids, here's the deal. You can use equipment, we'll get you the materials, what else we don't have, you got to come and get. Whatever you sell, it's 50-50. You get half, the program gets half. Because I got to put money back into buying bits and stuff. Buying Campbell's finish for my mirrors and stuff. So they get 50% of the profit, I get the other 50% for my program. Now, when that student graduates, I have a special account set up for him with our bookkeeper. Seminole Manufacturing, Nick Brettweiser, 5702. That's his account. So when Nick graduates, this is our plan. We're doing it this year. We only started a little bit last year. But our plan is for every product that kid sells, they get half of it. When they graduate, they get a scholarship, and that scholarship is what they had in their account. Now, what do you think? Kids like it. They're like, "We're going to get some money?" I said, "Yeah, you going to buy your car?" "I'm going to give me a car." I asked this one kid, I said, "What are you going to buy?" "I'm going to buy me some tennis shoes." I'm like, I don't get it, Air Jordans. But that's the thing. We're getting the kids incentivized. We're not just teaching them how to be good employees. We're trying to teach them how to start and run their own business. Don't be the dancing monkey that the organ grinder's just spinning harder and harder. You become your own boss. You come up with your own products. And what they're finding out, I had this one kid, he's an international sailor. He's going to be competing in Cyprus. Very smart kid, uber sailor. He came to me and says, "Mr. Platt, who buys the most stuff?" I said, "Well, look around you. Do you think those girls have better clothes than you?" "Well, yeah." I said, "You think they got more money?" "Yeah." And so they're the ones that buy the stuff the most. So anyway, we got to keep going here. So he's now making makeup containers for girls that they can come put Estee Lauder makeup kits in, makeup inserts. Thought it was kind of neat. We're almost done. Okay, 5 minutes.
We mentioned this earlier. Students need to show an industrial portfolio along with their school projects. One thing I think you can do that's really important, every teacher should do it that teaches industry, and every machinist that I've ever met always had something in their box that they made in high school. Every single one. A square, a hammer, something. When your freshmen come in, help them to make something that they can hold on to and have in their portfolio for a long time. Has to be something usable, practical, that they can do. And you can come up with those things. You really can. They've been drawing Sun Hydraulic parts, as I mentioned earlier. Go out into the community. Here's something that I noticed. We were making projects, the school was, and I go down and critique things. The bubblegum machine's a great example. I gave them the plan for the bubblegum machine. And this is one they built initially. And the kids call me up, and I go down there, and I say, well, you know.
We got 3 minutes.
We need to make some changes here. And I make the suggestions, and then they make the changes. And I critique what they're doing. And they fix it up, and then this is a finished machine that actually works. This one doesn't work, actually. The gumball can't get down in there. How about that? Can't get the gumball into the path.
There it is.
And this one works fine. So I went down and I said, well, think about this and do this. But challenge them to draw real products. Now, what I noticed was the children would be designing a jewelry box. And I would look at their numbers and it would say 8.204 or something. And the problem is that they say, well, that's good enough for me. That's okay. And for their jewelry box, it's probably okay. But when you have them modeling a real life product, like this valve, which they modeled, they need to measure it and model it right. It gives you a standard to grade their progress on. Go out into industry and say, hey, can we get some of your rejected parts so our students can draw them? And then you grade them on the model. And you take the model, create a PDF, and send it out to the industry that gave you the part and say, look what our students drew with your parts. Now, if you had a student drawing Sun Hydraulic parts, and they go to Sun Hydraulics for an interview, and they're interviewing, they say, oh yeah, I know about your company. When I was in high school, we used to draw all your valves and stuff. Do you think that could have an impact? It very possibly could. Valve inserts they drew, manifolds. This is a manifold that we make. These are out of acrylic. We make them out of aluminum, but it gives you an idea of what's involved, all the machining and the threading in the process. Sun Hydraulics, you can qualify for an internship there, go through some interviewing process, and if you are qualified, they would take you on as an employee, an intern, and allow you to work there and make some money. Columbus, McCain, and Rich is going to talk about them for real quick.
1 minute.
1 minute.
Okay. One of the things that we did, with Sun is that they gave us stuff that we could do. We had several businesses in Sarasota that make parts, and they're using SolidWorks. This is a cutter that's used to grind up tires. Columbus McKinnon's business is they make machines that recycle tires, and they've been wildly successful. 50% of their revenues come from overseas. This particular cutter right here will grind up a 10,000-pound tire. Maybe like go to a copper mine, you see those 8-story tall trucks. In Chile, they've got 250,000 of those used tires they got to do something with. So one of the things that we went and we visited them, they said, hey, you guys know how to use SolidWorks? And we said, yeah, we're trying to find stuff we can model, in class. Guys, we got a job for you. And I said, what? He goes, 30% of our product that we still sell is done in AutoCAD. Really? We want you to model that in SolidWorks for us, and we'll check the drawings. I mean, you talking real stuff, guys? It's absolutely real stuff. So we got, you want to be careful, these are really sharp. But they've given us their product that's still in AutoCAD format. They're on to other new designs, but they need to get the other stuff into SolidWorks. So my seniors are now taking on product line that they have and designing it in SolidWorks. And so they'll come in with their ukulele, and a cutter and a valve that shows real world stuff. Just like I did when I came out in NASA when I graduated from college. I had real stuff I'd done on shuttle, but now these kids are being able to get the same opportunity. That's powerful. You know, making a jewelry box and a ukulele and toy cars, that's neat stuff. It's fun. This is going to get them a job.
Right.
And it's going to be something that they can come in and say, yeah, I actually got to work in their factory. It's pretty cool. Listen, we've ran out of time.
Hit your button, Rich.
Oh, sorry. We've ran out of time, and we appreciate your patience with us, and these are the parts that we designed. And in summary, partnering is fundamental to a STEM educational lab. Otherwise, it's just going to be a fad. All it is a fad. It's the next buzzword that the politicians are talking about. If we don't bring industry, we're going to fail. And we got to commit our time and resources. Education is fundamental. That's what Russ and them have told us. I'm sorry if I jumped in there, Russ. But Sun feels that this is a strategic decision to do this with us.
Right.
And the problem is not education or not enough money. Money can be a problem. The problem is that, you know, we've got to get teachers with real experience out there in industry. We appreciate your time, guys. Thanks a million.
One more.
Okay. And we got to get the educational decision makers to understand that STEM is an applied thing. It's making stuff, designing stuff, getting out there with the industry.
One more.
Okay, one more.
There you go.
Any questions or comments? If you want to come up and see what we got, we appreciate it. We're going to be packing up.
Thank you very much.
You guys okay out there? All right.
Yep.
Appreciate
Appreciate
it.
it.
Like the bouncers fixing to get us out of here.
Did it. Southeast Glencoe Woodworking. Can look them up on the website.
Thank you very much.
Oh, absolutely,
Appreciate
absolutely. Any ideas you need from them, we're glad to help you on it. This is a 2x4 here. That's the one the girl did. We found out that using 2x6s, you can build a bigger toy, mills out easier. And so we started, our next tutorial set would be based on a 2x6, and the wood is better quality than a 2x4 stud. And then this stuff is awesome. Great for learning how to do mates in SolidWorks too. It's like on the lockbox, and there's these toy puzzles. You can find these puzzles all over the place. But what it does is it teaches the complex mates based on, you know, different angles or planes or whatever.
Anybody that's interested in anything, take my business card, shoot me an email, put SolidWorks World 13 in the subject block so I know what it is. We'll send you back anything you want.
Yes, I do.
Drawings,
Where you teach
models,
at?
whatever.
Cherokee Trail High School in
PowerPoints.
Colorado.
Oh, Aurora, all right.
More than happy
My
to
son
help
was
you out.
born in a Swedish hospital. Yeah. We lived up there in the early 90s, and he was born in 92 up there. Yeah. I lived in Castle Rock, right there behind the outlet mall. Yeah, so in the Meadows, I think it's named the subdivision. Yeah, I had to move back to Texas when I was working at Intergraph then, and I left there and I went to work for Silicon Graphics. And, you know, I was the guy that provided the computers for CAD, you know, sales and stuff. But I got tired of traveling. He got good at baseball, and so I became a school teacher. But, you know, the funny thing, here's something else we learned. This stinking ukulele. The kids and I fought this tool path on the neck forever. And then, you know, assembling it and putting it together, what we found out, you know, okay, we made a $100 ukulele, big deal. We found out that if we would have made a solid ukulele, it's easier to mill, it's easier to glue up, and you go from a $100 ukulele to a...
Is this laser?
No, this was milled out. This was milled out. The laser we used on putting in the frets, but the tool path on this guy was a beast. And we found out that if we would have done the box, if we'd have done the whole sound box as a two-piece solid, vastly easier to make, because this is incredibly labor intensive. So we couldn't make any money doing these.
I'm the drafting and engineering teacher, but the woods teacher and I are partnering on we're going to start guitar making.
Yeah.
So that's cool that you guys did that.
Yeah, and the thing about it is, it's, you know, if you do, I would really look, if you got a CNC router, a big one, I'd look real hard at doing a two-piece. It's better quality, and if you sell these things, I mean, they're beautiful. They are absolutely gorgeous. Good source of woods that, like when I can't get good stuff from him, I'll get out on eBay and I'll start looking at some of the burls and the crotch maples and all that kind of stuff.
How do you deal with the money aspect of your school district works with you really well? You have, and you said the kids were selling stuff on eBay.
Mm-hmm.
How do you handle that?
The big thing that made us the money as far as products that we produced initially, now we haven't gotten into full manufacturing, selling stuff on Etsy yet. That's the goal this year. At the end of this year is to be doing that. Where we made the most money, stupid as it sounds, is those 80-cent dog tags. using a laser engraver. I mean, those kids will run those machines till they're, I had to, 2 days after school was over, I said, you guys go home. I've got my grades done. I'm going away for the summer. And then I finally ran them out the door. And then we were serious about tracksters. But the thing that made the money was buying leather straps, go to the Tandy store, and where do you live? In Wyoming. So in Denver, they're probably going to have a Tandy store where you can get online. They sell bulk. They sell bulk leather in just strips. You can get them for like $1 a strip. You can take and put a grommet and snap on it, laser engraved like Tommy Loves Janet, or something like that on it. They go crazy over that stuff. So you can sell those for $10, $12. The diplomas, laser diplomas, $35 to $40. Those make you good money on that stuff. And then other things we do is the mirrors have started coming on real quick. But that's why when you're talking about like making the guitars and the ukuleles, go for high volume, high value. I will never make that again. I put a bullet in my head before we make another one of those. And the kids are like, God, Mr. Platt, this is hard to glue up. I'm like, well, yeah. We had to find bendable plywood, which is hard to find. And you have to soak it, and it's nasty. But our IB kids are the ones that, they blow me away. My TSAers, our TSA, we're real competitive in TSA. We're nuts in it. And we're pretty decent. But the thing though is, what I found is the IB Design Tech kids are the ones, like I'm not letting my TSAers touch that mill. They don't touch the big mill. The Design Tech kids are the ones that are going to paint it and assemble it and get it ready to go and operational. Absolutely.
Yeah.
That
website you talked about, where you sell your products, what was the
ETSY.com.
ETSY?
It's awesome. I have a cousin who, real sad story, he lost a daughter to a blood disease, and he's been kind of recovering emotionally from it, but he's one awesome cabinet maker just outside of Houston. And he told me, he said, man, I'm making $600-700 a month just selling little jewelry trinket stuff on it. And I looked at some of the stuff. His mirrors, I looked at his mirrors that he made. He can't make anything like this. And he's got good stuff. He cannot make anything of this quality. And we just got started. We were just using a freaking quarter-inch ball nose on that. If I'd have gone to a 16th or a 9/64, the level of quality and detail we could have got so much better. And then, other thing, on your software, you need to look at, if your school board requires you to use Mastercam, then use it. Take a hard look at VCarve Pro and Aspire.
We're using we have Roland,
Mm-hmm.
and so we use the SRP,
Okay.
but we also have access to CamWorks.
Yeah.
So
Take a look at VCarve Pro, Aspire. VCarve Pro, $600. They have the best tutorials. You can download it for free. And it's full.
friendly, easy.
Oh,
Yeah.
Let me.
that's what I use in our shop. And you can do everything with it, with the trial, except for it only generates so many lines of code. It'll even let you generate small code. But it's designed for CNC routing. And I can go in there and make a program in seconds, minutes.
And that's VCarve.
Yeah.
VCarve Pro.
Yeah, I downloaded their free.
Oh, it's awesome.
For dragsters, this is my website on this is on how we did the toy car project where the kids, go out and make the little trucks and all that kind of stuff. And what I have is video tutorials and all this. This is the one on the hand mirror where you come down, you click on one of these. Well, of course, I don't have the right. No, this is with SolidWorks. Now, what happened was my teachers, they get real picky about stuff after you've given something free. I get up I'm a kind of a maniac. I get up every morning at 4 o'clock. I like to get up in the morning early. So I get up and I'll make tutorials. Well, they came back to me and said, well, hey, on this CAD cam stuff, we bought CamWorks countywide. I think you need 2 cam apps. I don't think you should be a one-trick pony. We can't afford Mastercam. CamWorks for 500 seats across our county was 4 or 5 high schools, I don't know how many middle schools, was $36,000 every 3 years. And so we bought that. Well, what I did was they got all upset because I did all the video tutorials. Why don't you write something up for reading stuff? I said, okay, play that game, I'll write it up. They're always arguing about something. No, man, these are my fellow freaking teachers. The guys I compete against at TSA in Nationals, Lakewood Ranch. And so what I did was I said, okay, I'll help you out. So I wrote up 100 52-page, 6-chapter book, on how to mill out a dragster. I mean, so you come down through here, I go into detail ad nauseum and how to use CamWorks to actually mill that out. And then you get down in it, you can print these off, I don't care. And like, smooth cuts on the dragster and stuff like that. I put all this stuff together. And you know what was funny? What was so funny about this? The kids read it and mastered it. The teachers never did. And I'm like, it's so funny one day. I said, well, tell me. I said, I had this one teacher come and complain, and he says, well, Platt, I did this, and I think you got a couple settings wrong. I said, well, do tell. So I kind of drilled down into what he was asking me. And what he had not understood was the step over rate on some of the inside radiuses on a shell car. And so and then the kids, they're all going like, come on, man, you should have known that.